Welcome to The Explainer. Today, we are diving headfirst into the data, the physics, and the literal shifting ground. Well, shifting waters, right beneath our feet. We're talking about global sea level rise. We're going to break down exactly what happens when Earth's massive ice welts start to thaw and what that actually means for the future of our coastlines. It's a lot to cover, and we're moving fast, so let's get right into it. Here's our roadmap for today. First, the global water vault. Second, climate tipping points. Third, redrawing the map. Fourth, the human cost. And finally, frontline crisis, the Seychelles. Section 1. The global water vault. Okay, so when you and I think about water on Earth, we usually picture the oceans, right? Those vast, deep, salty bodies of water. And it makes perfect sense because, according to the U.S. Geological Survey, they hold a massive 97.2% of the planet's water. But it's that tiny, tiny sliver left over, just 2.1%, that we absolutely need to focus on today. This 2.1% is all the water on Earth that is currently frozen in glaciers and ice caps. And here's the truly wild part about that tiny fraction. It actually represents roughly 3/4 of all the freshwater on our entire planet. It's literally the largest reservoir of freshwater we have. Think of it as a massive global vault of locked-away ice that quite literally dictates the shape of every single continent on Earth. Now, this frozen water isn't just evenly sprinkled across all the snowy mountaintops of the world. No, it is heavily and dangerously concentrated. A staggering 91% of it is sitting squarely on the continent of Antarctica. Another 8% is locked up in the massive ice sheets of Greenland. That leaves a mere 1% for literally all the other mountain glaciers and ice fields scattered across the rest of the globe. So when we're talking about Earth's freshwater, we are fundamentally talking about just two gigantic ancient pillars of ice that are holding back the oceans from the rest of the world. The stability of our current coastlines, it relies entirely on those two specific regions staying frozen solid. So what happens if those ancient pillars fail completely? If all the glaciers and ice caps on Earth were to suddenly melt, global sea levels would rise by approximately 70 meters. That is about 230 feet of vertical water. To put that into perspective, imagine standing in the middle of any major coastal city: New York, Tokyo, London, Mumbai. Now picture the waterline rising all the way up to the 20th floor of the skyscrapers around you. At that level, every single coastal metropolis on the planet would be completely submerged. Now don't panic, a total melt is not a scenario projected for tomorrow or even the next century. But grasping that absolute, mathematical worst-case limit is crucial. It sets the sheer scale of the threat. It perfectly illustrates why even a tiny, fractional percentage of this ice melting spells an unprecedented geographical disaster for humanity. Section 2. Climate tipping points. To truly understand how these ice faults behave, we have to look at the laws of thermodynamics and a super important scientific concept known as hysteresis. It's a bit of a dense word, but in simple terms, hysteresis means a system is path-dependent. Think of it like this. Imagine holding a fragile glass and dropping it on a stone floor. It shatters. You can't just pick up those broken pieces, set them back on the table, and magically have a fixed glass, right? The system is fundamentally broken. It's permanently changed. Well, the exact same principle applies to immense ice sheets. If you warm the planet and an ice sheet begins to collapse, you can't simply cool the planet back down to its original temperature and expect the ice to just rebuild itself. You would actually have to plunge the planet into a significantly colder state for thousands of years just to even begin slowly reaccumulating what we lost in mere decades. We can actually see the tragic reality of this irreversible loss in the data from the Potsdam Institute for Climate Impact Research. Notice the upper pathway there. That represents the rapid retreat of the Antarctic ice sheet as global temperatures rise. But then look at the lower pathway. That represents the ice attempting to slowly regrow if we actually manage to drop temperatures back down. See that massive blue shaded gap between the two paths? That gap right there is the hysteria. It represents irreversible ice loss. It shows us that once we push the climate system too far, we essentially fall off a cliff. We literally cannot just walk back up the exact same path. Once that ice is gone, for all practical human timeframes, it is gone forever. And the data actually gives us the specific milestones, the physical triggers that push us right over that cliff. At just 2 degrees Celsius of sustained global warming, we commit the West Antarctic ice sheet to a long-term, irreversible partial collapse. If we push further, hitting between 6 and 9 degrees of warming, we trigger a totally catastrophic 70% loss of our present-day ice volume. That specific trigger translates to over 40 meters of sea level rise. And if we ever cross the terrifying threshold of 10 degrees, Antarctica crosses a tipping point where it becomes virtually ice-free.
These are not just random numbers on a thermometer. They are permanent physical thresholds that will literally rewrite the future map of our planet.
Section 3, redrawing the map.
Okay, let's pull back from the deep, long-term future and look at the immediate geographic realities of the next 50 years, as modeled by the UMAP Journal. In a highly optimistic, best-case scenario where we somehow limit warming to just 0.7 degrees over the next half-century, seas still rise by 9 centimeters. In a worst-case scenario of 2.9 degrees, we're looking at a 21-centimeter rise. Now, I know what you're thinking. It's incredibly easy to hear 21 centimeters, which is just about 8 inches, and think, well, that sounds harmless. But here is the absolutely crucial concept to understand about sea level rise. 1 unit of vertical rise translates to roughly 100 units of horizontal coastline loss. Imagine a gently sloping flat beach. If the water simply comes up an inch vertically, it has to push feet or even yards horizontally inland just to find that new resting level. A few vertical inches of water means entire sandy beaches, barrier islands, and low-lying coastal ports simply vanish off the map. As this water aggressively pushes inward, humanity is really leaning on 3 primary adaptation strategies. First up, defensive structures. We're talking engineering marvels here, like massive seawalls, tidal barrages, and huge pumping systems. Second, nature-based strategies. This is where we attempt to restore natural buffering land states, like coastal wetlands and mangrove forests, that basically act as giant sponges for incoming storm surges. And third, we face the most drastic and complex strategy of the bunch, managed retreat. Now, managed retreat isn't just a clinical term. It means deliberately abandoning generational homes, shutting down vital infrastructure, and physically moving entire communities inland. Trying to implement any of these strategies, let alone managed retreat in coastal environments that we historically assumed were perfectly eternally stable, it's proving to be a logistical and financial nightmare.
Section 4, the human cost.
2 billion. Just let that number sink in for a second. According to some deeply sobering research from Cornell University, by the year 2100, the encroaching oceans could result in 2 billion climate change refugees. We are talking about roughly 1/5 of the entire projected human population being forced to pack up their lives, leave behind submerged coastal zones, flooded river deltas, and sinking island nations, and desperately seek higher ground. Charles Geisler, one of the lead authors on that Cornell study, summarized the impending crisis with a truly profound warning. He said, "We're going to have more people on less land and sooner than we think." And that really highlights a terrifying geographic bottleneck. You see, the crisis isn't just that 1/5 of humanity has to move. The true crisis is that the sheer amount of habitable, arable land available to actually receive these billions of people is shrinking inward at the exact same moment our global population is expanding outward. The barriers to executing this massive inland resettlement are compounding at an alarming rate. By 2100, our global population is expected to reach 11 billion. But as the oceans take away the edges of our map, we are simultaneously losing the center of our map. Widespread desertification is turning previously fertile inland areas into dust. Relentless urban sprawl is paving over whatever arable land is left. Essential natural resources, particularly fresh groundwater, are being rapidly exhausted, and vast tracts of land remain completely unusable, tainted by the residues of war and industrial contamination. We are facing a severe, unprecedented squeeze. Finding safe, fertile, and stable land for 2 billion displaced people is a logistical crisis on a scale that humanity has literally never even come close to facing. Section 5. Frontline Crisis, the Seychelles. Let's ground this in reality. The Republic of Seychelles is a stunningly beautiful, small island developing state located in the western Indian Ocean. It's a nation known for pristine beaches, totally unique biodiversity, and a really rich cultural heritage. But for the people actually living in the Seychelles, sea level rise isn't some distant theoretical model projected for the year 2100. Because of their extreme geographic vulnerability, it is a daily, multi-layered threat to their sheer survival, and it's most acutely impacting their ability to simply feed their own citizens. Food security for the Seychelles really rests on 3 distinct pillars, and right now, all 3 are cracking under pressure. First, their local production is fundamentally hindered by naturally poor soils, incredibly small farm sizes, and increasingly extreme weather patterns. Second, their reliance on international trade is brutal. They suffer from some of the highest shipping transport costs in the world and have incredibly low bargaining power on the global market. And acting as an aggressive threat multiplier to both of those vulnerabilities is the third pillar, climate change. It is actively and relentlessly attacking their fragile ability to sustain themselves. And this climate threat is actually attacking them simultaneously on two inescapable fronts. On land, the creeping, rising sea levels are forcing saltwater deep into the coastal soil. This saltwater intrusion permanently ruins their incredibly limited agricultural land, essentially poisoning the soil right from underneath them. At the exact same time, out in the ocean, rising water temperatures are triggering massive, localized coral bleaching events. These bleaching events devastate the vibrant reef ecosystems, which in turn annihilates the artisanal fisheries that the population heavily relies on for their daily protein. So their land is being poisoned by salt, and their reefs are being bleached of life by heat. It's a devastating double whammy.
The Seychelles is the undeniable canary in the coal mine for our global coastlines. Throughout this explainer, we've seen the undeniable physics of the ice faults. We've mapped out the irreversible tipping points of a warming climate. And we've witnessed how rapidly the habitable map of our world is shrinking. So as we wrap up today, I want to leave you with one profound, unavoidable question to deeply consider. With rising seas threatening to displace 2 billion people over the next century, and the amount of habitable, fertile land rapidly shrinking, where will we all go? Thanks so much for joining me on this explainer today. Keep questioning, keep learning, and I'll see you next time.